Now that we've got some good building blocks, we can start talking about different algebraic expressions and kind of build a collection of algebra topics and procedures. So we had previously mentioned the idea of a term. It's an expression that doesn't have any adding or subtracting that appears. What we're going to do is we're going to take that idea and we're going to say that a single term could be referred to as, instead, a monomial. Mono, one, so monomial referring to one term. That allows us to now talk about a general category, things that have many terms. So many, poly. Polynomial, meaning many terms. So monomial, one term, binomial, two terms, trinomial, three terms. Those are the specific kinds of expressions that have a specific name that's connected to them. After we hit three terms, we don't have any special names, and we would just say, generally speaking, any of those monomials, binomials, trinomials, and anything with more terms would be called a polynomial expression. Normally what we would want to have is some nice way of writing these out. And so there are two understandable ways. Either start with the regular number stuff and work your way up to the highest power, or the flip-flop, start with the highest power and work your way down to the plain old number that shows up. Traditionally, higher powers at the beginning, working our way down towards our plain old number. One of the reasons is that other than referring to the number of terms, we can classify polynomials based on the highest power that shows up. The highest power that shows up usually is attached to only a single variable. Multiple variables, a little bit funkier, we'll deal with that in another little bit. But for most of our work, one variable shows up throughout that polynomial, so we very quickly look for what's the highest power that shows up. And that's what we would normally like to write at the beginning. That's what we refer to as the degree. So a polynomial that has a highest power of 4, we would say fourth degree, or degree 4. One of the things that we also might comment on and would eventually be useful if we go deep enough into algebra is the leading coefficient. Like the name suggests, leading. If we have written things in the traditional order, highest power stuff at the front, then the leading coefficient is going to be leading, the beginning, coefficient, number part. So the coefficient, the number part of the term that has the highest power in it. When we work through an example here in another moment, I will go ahead and make specific mention of the degree and the leading coefficient. But let's bring back something else that we had already mentioned before for simplifying those expressions that we've seen already a little bit. Well, we've actually been working with polynomials without flat out saying so. And we said with adding and subtracting, combining like terms is the nice, quick phrasing to use. So apples with apples, oranges with oranges. Like terms that have x squared, like terms that have x to the power of 5, like terms that are just constants. To add and subtract, we combine like terms. So we're doing things that we've already seen a little bit of, and we're going to take a look at two specific examples, one for adding, one for subtracting. But remember again that the basic idea here is like saying, well, the 11 x to the power of 5 minus the 8 x to the power of 5 would end up giving us a 3 x to the power of 5. And with our plain old numbers, a negative 4 minus 23, those are like terms, and we can combine those together. And if we've got several different kinds of terms, whatever can be put together gets put together using like terms. Whatever is different stays separated. So for instance, here in this first example with these longer expressions, what we have without the parentheses in our way is a 17x to the power of 4 minus 3x squared plus 11x minus 10 plus x to the power of 3 minus 2x squared minus 22x. Now if we go looking through here, what we would like to try to do is first of all pick out what term or terms have that highest power. So we start looking through. We've got power 4. Well, power 4 is the biggest power, highest power. Only one term has that power of 4. So according to our convention, that 17x to the power of 4 is going to be the first part of our answer. Then we want to go ahead and move down through our powers. So the next power that we would want to put in there, if it shows up, is going to be a power of 3. So we go looking, here's a term that has x with a power of 3. It's the only term that has x with a power of 3. So this is going to be the next part of our answer. Then we drop down to the next power, which would be a power of 2. And we go looking to see if we've got any terms that have x with a power of 2. We have not just one, but 2 terms. So here's where we bring in our combining like terms idea again and say, I need to put together this minus 3x squared and this minus 2x squared so that my final answer would have a minus 5x squared. And then drop down again from a power of 2 to a power of 1. Well, the power of 1 is not typically written down, so what we're really looking for is just a normal x, and we have 2 terms with a normal x appearing. So those 2 terms are going to be like terms that we combine together. In our final answer, we would have a minus 11x. And notice that the only thing that hasn't been underlined is our constant term here, minus 10. So that would be showing up at the very end of our answer. One way of classifying this answer is to refer to the number of terms. 1, 2, 3, 4, 5. This has 5 terms. Another way of classifying things, though, is based on that highest power, which was how we started to build our answer. And that highest power that we saw was a power of 4. So, a little side note here, the degree is 4, and the other vocabulary term that we had mentioned was that leading coefficient. And that leading coefficient, again, the number part of the very first term that has that highest power showing up, the number part that shows is a 17. So our leading coefficient here would be 17. The other example, subtraction, my comment to you, be careful with the subtraction problems. Remember to distribute your subtraction. So if we wanted to actually be super careful about working through that, our first set of parentheses can just be discarded, but our second set of parentheses, we need to make sure that we distribute our negative. So a minus with our x to the power of 3, turns into a minus x to the power of 3. Our minus with the negative 2x squared would turn into a plus 2x squared. And our minus out in front of the parentheses with the minus 22x would turn into a plus 22x. And now I can go through and search for the highest power that's attached to my variable x. That highest power is, again, a power of 4. So the one term with x to the power of 4 is going to be at the front of my answer. Then I drop down to the next power, a power of 3. There's only one term with x to the power of 3 showing up. So that's the next part of my answer. Then I drop down to a power of 2. There are two terms with x squared in them. So I combine those two terms together for the next part of my answer. Minus 3x squared plus 2x squared gives me a minus x squared. Drop down again from a power of 2 to a power of 1. Power of 1 doesn't actually get written down very often. So what I'm really looking for is just a normal x. I have two terms with a plain x in them, plus 11x plus 22x, giving me the next part of my answer, plus 33x. And then any constants that appear, well, there's only one, the minus 10. And because I wasn't feeling particularly creative in building these two examples, the degree is 4, the leading coefficient is 17, just like the previous example was. And we have a total of 5 terms, also like the previous example. So not a lot of variety here between those as far as classifying things. However, you do want to make sure that you are working through things carefully and using your combining like terms. And that would even be the case, as you can see down here, if we have several variables that show up in our problem. If we have several variables that show up in our problem, our idea of combining like terms still holds. The only issue would be, how do we classify things? Beyond the number of terms that show up, how do we tweak the notion of the degree so that we can account for several variables showing up? And what we have to do is this. We're going to look at each term one at a time. Any variables that show up, we take the powers and we add them together. So the degree of the term. Add up the powers of the variables in your first term. So here's an example. Power of 3 plus power of 1, give me a degree of 4. Power of 1 plus power of 2, give me a degree of 3. X by itself has just a power of 1, so degree 1. Y by itself, degree 1. Plain old number does not have any variable stuff, so we would consider that degree 0. Once I have each one of those, now I still look for the highest, but this time it's a slightly different phrasing. What's the highest degree of term? So out of this list, the highest degree of term is a 4. So for my entire weird-looking polynomial, the degree of the entire polynomial, 4. That's the only weird thing about it. And again, if you need to, there it is. As far as adding and subtracting goes, you're looking at using the idea of like terms, combined like terms, as long as the letters, the variables, and their corresponding powers match up. So x to the power of 3 and a y. If I had another term with an x to the power of 3y, then I could go ahead and add those together. X, y squared. If there was another term or two more terms that had x, y squared in them, those could be combined together. So that's the way that I would do things if I had to worry about polynomials that had several variables in them.